Hello and welcome to this video on types of sequences. So we're going to be looking at working out the values in term-to-term sequences first. I'll explain what that is in the moment. Then we're going to look at some of the other terminology around the different types of sequences that you might come up against in your GCSE exam. Okay, so the first type of sequence we're going to look at here is what's known as a term-to-term sequence. So what that means is you've got to go from term to term essentially just to get each number in the sequence. So you can't work out the 100th term in the sequence without knowing the 99th, or you can't work out the 20th without knowing the 19th. Okay, so it's a little bit different to some of the linear sequences that you might come across. So if we look at this example here, we've got the first two terms here. So we've got 2 and 8. And it says the term-to-term rule for this sequence is to multiply by 3, then add 2. So pause your video, see if you can have a go at this yourself, then we'll take a look at the answer. Okay, let's have a look at the answer to this then. So first of all, we need to multiply that 8 by 3. That will give us 24. And then we've got to add the 2. And that will give us 26. So as you can see, not too bad to go from one term to the other. You've just got to follow what the rule is in. But the rule will usually be in words on these. So it's just about reading it carefully, really. Okay, let's have a look at a slightly trickier one though. So on this particular sequence, you're told that the third term, so just the third term is 6. We don't know anything else. And this time we're going to have to work backwards. So you're told the term-to-term rule is multiply by 2 and then add 4. But we're going backwards to work out the first term. So think about how you would be able to reverse that rule. So pause your video and have a go. Okay, let's take a little look at this then. So we're going backwards first. So we need to get that second term. Remember, we've got to go from term to term. So we're going to reverse this now. So the opposite of adding 4 is subtracting 4. So if we take 4 off that 6, we'll get 2. And then the opposite of multiplying by 2 is dividing by 2. So if we then do 2 divided by 2, we get 1. So now we know the second term. So we now know that that's 2, that's second term in the, sorry, not 2, that's 1. That's that second term in the sequence. So now we're going to go from 1, our second term, to get that first term. So remember again, the opposite of adding 4 is to subtract 4. So if we take that away, we'll get minus 3. Then we've got to divide by 2. So minus 3 divided by 2 will give you minus 1.5. Or you can write this as a fraction if you want to. You can write minus 3 over 2, so minus 3 halves there. Either way would be accepted as a valid answer for this particular question. Okay, let's move on now to looking at some of the other terminology. So we've looked at term-to-term sequences now. We're going to look at some of the other words that you might come up against in the exams. So this is actually from a past paper question here. We've got 6 different types of sequences here. Now there's already one that's given to you here, which is this Fibonacci sequence. So a Fibonacci sequence is where you add together the previous 2 numbers to get the next number. So there we've got 1 to start with, so we have another one. Then we've got 1 add 1 to make the 2. Then we've got 2 add 1 to make 3, and 3 add 2 to make 5, and then 5 add 3 to make 8, and so on. So that's what's known as a Fibonacci sequence. So what I'd now like you to do is just pause your video, see if you might know some of these terms already perhaps, see if you can figure out what the other sequences of numbers are. Okay, I'm going to start with the more straightforward ones then. So this one here should be square numbers because we've got 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, and so on. So that's probably the most straightforward one. Then we've got your cube numbers down here. So cube numbers, we've got 1 times 1 times 1, which is 1, 2 times 2 times 2, which is 8, 3 times 3 times 3, which is 27, and so on. If we look at some of the others then, so this arithmetic progression, so an arithmetic progression is an addition or a subtraction by the same amount each time. And the only sequence that does that is this one here. Okay, so because we're going up by 1 each time, we're going 1, 2, 3, 4, 5, 6. If you reverse that and went 6, 5, 4, 3, 2, 1, that would also be an arithmetic progression as well, but that would be a subtraction. So an arithmetic progression, remember, is always adding or subtracting by the same amount each time. Now, geometric is all about multiplication. So if we look at this one here, this is our geometric sequence. And the reason it's geometric is because we are just doubling the number each time. So your next one after that would be 64. So that's a geometric progression where you're multiplying by the same number each time to get the next number. And then the last one is triangular numbers. Now, this sequence here, obviously, is the triangular because it's the only one left. And I'll show you why visually in a minute why it's called that. But if you have a look, you will notice with this sequence, the difference is increasing by 1 each time. So first we're going up by 2, then we're going up by 3, then by 4, then by 5, and so on. And this is why it's called a triangular number, because you're starting with 1, then you're adding 2 to get that 3, then you're adding 3 to get that 6, then you're adding 4 to get that 10, and so on. You'll see it makes a nice little sort of like triangle here, and the base of that triangle is just increasing by 1 each time. Okay, let's have another look at another question then. So this again is from a past AQA paper. So we've got some numbers there, and we're given an example of an arithmetic progression. So now we need to use 3 of the numbers to make a different arithmetic progression, and we need to describe the rule. So there's a few different right answers for this one. So pause your video, see if you can find them. Okay, the most straightforward one we could find here is just to reverse that and just put 20, 15, and 10. And our rule would be subtract 5 each time. You just need to describe the rule in words, essentially. Some others that we've got, we could have, let's see, we could have 13, 20, and 27. So that would be add 7 each time. You could also do the reverse of that, starting with 27 as well. We could also have 15, 27, and 39, and that would be to add 12 each time. And you could also do the reverse of that as well, because remember, an arithmetic progression is where you are going up or down by the same quantity each time. Okay, final example then that we're going to look at is this geometric progression. So pause your video on this one and have a go. And as you can see there, the answer here is 64, because all you've got to do is multiply by 4 for that one. Okay, because the geometric progression means you're multiplying by the same number each time. And the reason why it's 4 is because you have to do 4 times 4 to get 16. And I'm just told you a lie on earlier. We've got one more question to do before we finish. So we've got this Fibonacci sequence. So on this one, remember, Fibonacci sequence is where you add together the previous 2 numbers to get the next number. So I want you to figure out the next 2 terms here. Okay, our next term then, we need to add 3 to minus 8. That will give us minus 5. Then we've got to do minus 8, add minus 5, and that will give us minus 13. So those are our next 2 terms. Okay, and that's it for this video. So thank you very much for listening. Please hit subscribe and you'll see loads more videos coming your way to help you with the GCSE Maths Foundation syllabus. Thanks very much. Bye.